Hello everyone, I am Farheen Qazi from Sasad University of Engineering and Technology. My research paper topic is Secure Identity-Based Cryptographic Approach for Vehicular Ad-hoc Networks. Here is the presentation plan. First we discuss about abstract. Number of vehicles on the road has increased in recent years. Potential threats and road accidents are increasing because to the high density of all these vehicles. In order to reduce these factors, wireless technology is designed to equipped in vehicle technology by sending messages to each other, known as vehicular ad hoc network. The optimal goal of this research is to provide timely information to drivers and concerned authorities so that vehicular networks will contribute to safer and more efficient roads in the future. To achieve the above mentioned goal, there is need for substantial research in the area of security for the possible deployment of VANET in near future. In terms of architecture, implementation of identity-based cryptographic schemes has been studied in order to provide better security and privacy for VANET, as it is considered as a viable choice due to the properties of VANET in comparison to the traditional public key infrastructure approach. Introduction. VANET is used to provide safety, security, and convenience to the automobile travelers, and it can be beneficial to warn the drivers for any possible collision that can occur on their way, along with the automatic payments for the parking and for the toll collection. Communication between vehicles and nearby roadside infrastructure technology can be made possible, and this whole procedure occurs because of the availability of wireless sensing devices that has been installed in the vehicle. Cryptography plays a major role to achieve security in any network. Many advanced encryption algorithms which are used for securing wireless network, however, cannot be used in VANET given that they have served power constraints and resource constraints since they are small sensing devices residing on a vehicle. The proposed study will first generate the frame by using the vehicle information and perform the authentication for the data. Then produce two keys KY1 and KY2 for the encryption and decryption procedure. This study will not only provide the encryption and decryption algorithm for the VANET, but also calculating the authentication code for the further key generation process by generating the frame, which is based on 8-bit strings. Previously developed methodologies. Chim presented a rich literature on public key management in VANET. Pradeep and Barreto used another approach which providing key material through a web of trust. Chaudhary also proposed a technique in which employs hardware that integrate both asymmetric and symmetric cryptography modules for safety messaging and used hybrid approach that take advantage of both asymmetric and symmetric cryptographic scheme. Prabhakar proposed a technique as an essential complement to the passive mechanism of encryption. Our proposed methodology based on frame generation, authentication process, key generation algorithm, encryption algorithm, and decryption algorithm. First, we discuss frame generation. For the proposed algorithm, we are generating the frame that helps in generating authentication code for any random selected automobile. The frame consists of 7-bit string. The first bit is called authentication code. The second is randomly selected frame number. Third one is the active bit. On the fourth, fifth, and sixth place, we are considering the vehicle related messages, which are roadside unit to vehicle, vehicle to vehicle, and vehicle to roadside unit respectively. In the end, we have the current frame number that can be able to identify which data field is currently updated. Here is the diagrammatical representation of the frame. As we see, authentication code, frame number, active bit, roadside to vehicle data, vehicle to vehicle data, vehicle to roadside data, and current frame number. These are the steps for authentication. Take the number plate of the vehicle as input ID, which is based on numeric and alphabetic value. Generation of authentication code is based on quadratic formula. Convert the alphabetic character into numbers by simply taking the cryptographic values of English alphabets and add all of them, as we see here, A plus B plus Z, and convert into numeric values according to alphabetic cryptographic values. Take the numeric part of the vehicle number plate and select its first and third number, as we see 1 and 2. Select constants of quadratic equation A, B, and C from step 3 and 4. Choose the largest number as constant B. The second largest number selects as C, and the smallest among all selects as A. As a resultant, we have two values and we choose positive value if it is an integer. Otherwise, select the negative value with the modulus. Take the square of the value obtained from step 6. Hashed vehicle ID is obtained by adding method of hashed value obtained from step 7. These are the steps of key generation algorithm. Key is the combination of authentication code and active bit by using XOR operation, where the active bit is obtained from third bit string of the randomly generated frame. Convert the value of authentication code and active bit into binary form. Applying XOR operation between authentication code and active bit. Taking 2's complement of the output obtained from step 3. After taking 2's complement of the key, perform 1-bit circular left shift, then split key into 2 halves, KY1 and KY2. Here is the diagrammatical representation of key generation. We can take authentication code and active bit, then convert into binary form, then applying XOR operation, taking 2's complement, circular left shift, and then split the key into KY1 and KY2. These are the steps of encryption algorithm. Consider any random data related to roadside to vehicle, vehicle to vehicle, and vehicle to roadside unit. Obtain the binary value of the data coming from step 1. Split data obtained from step 2 into 2 halves called data 1 and data 2 respectively. To obtain the updated data 1, perform XOR operation between KY1 and DT2. For updated data 2, perform XOR operation between KY2 and DT1. Concatenate updated data 1 and updated data 2 and obtain encrypted data. After this, applying 7-bit circular left shift on encrypted data and obtain the final encrypted data. is the representation, graphical or diagrammatical representation of encryption process. We can take the data of roadside to vehicle unit, vehicle or vehicle to roadside, then convert into binary form, then split the data into two halves, data 1 and data 2. After this, perform KY2 and DT1 XOR operation and DT2 and KY1 XOR operation, and then concatenate the data to get encrypted data, then perform 7-bit circular left shift and get the final encrypted data or ciphertext. These are the steps of decryption algorithm. Before applying the decryption procedure, according to the predefined criteria, first the roadside unit will authenticate the data by taking authentication code and frame value from the already generated frame and applying the complete procedure for the construction of authentication code. If the value calculated by the roadside unit is same as the value of hashed vehicular ID, then it will further proceed. Otherwise, it will discard the frame. After successful authentication operation, applying 7-bit circular right shift on final encrypted data to get encrypted data, split encrypted data into two halves and get updated data 1 and updated data 2, applying XOR operation on KY1 with updated data 2 and KY2 with updated data 1 and obtain data 1 and data 2. Concatenate data 1 and data 2 to get the original message or our plain text. Here is the diagrammatical representation. If we can get ciphertext, then perform right shift operation, then we get encrypted data and split into two halves, then perform XOR operation, and after this concatenate the data 1 and data 2 to get the original message. Experimental results. The proposed security suite is implemented in MATLAB. The frame and active bits are generated randomly for key generation process. The variation in both values indicate that there are huge randomness between data fields and randomly generated frames. Therefore, it may conclude that the key generation will always be a random procedure that enhances the security and almost impossible to decrypt the data. Here is a graphical representation of randomness in key generation and authentication code. The following table shows number of operations which are being used in overall procedure: authentication code, key generation, encryption and decryption. This concludes that the complexity of the procedure will increases due several number of operations that will ultimately enhance the security as well. We have the operation of XOR, 2's complement, left shift and right shift. In authentication code, one XOR operation is applying. In key, one XOR operation. In encryption and decryption, two XOR operations are implemented. In 2's complement is only once implemented in key. Left shift is applying on key once, and in encryption 7 times, and right shift operation is applying only on decryption 7 times. In the below figure, key generation time and authentication code time has been compared, showing their difference, the authentication time and key generation time. We have also made the comparison between the execution time of encryption and decryption of the proposed algorithm with the existing algorithm given in our research paper. The Blowfish, DES, TAN, IDEA are the already existing algorithm, and we compare our execution time with our proposed algorithm. And here's the decryption time comparison of our algorithm. According to the figures 6 and 5, it can be easily seen that the proposed algorithm showing better performance as far as the execution time is concerned. Conclusion: the proposed study has provided the secured communication between the vehicles and the roadside unit by means of new and much better authenticated algorithm, and given algorithm has also provided the secured communication in VANET. This algorithm has first generated the frame which is based on vehicle related features. Then after that, proposed algorithm will generate the random ID for creating the authentication code. The authentication code has used in the making of secret key for further encryption and decryption. Provided experimental results have also shows the performance of the algorithm, and VANET will safer and beneficial for IoT application. Thank you.